Hello all, welcome back to my channel Data Sculptor. So recently I have attended this ALCENTRA interview. So ALCENTRA is a group of Franklin Investments company. So there they wanted a data uh, engineer who's good at data modeling and uh, basically SQL and all. So I have attended this interview recently. So I thought of creating those all those questions into a video. So since there were a lot of questions asked, I grouped this all the questions into multiple videos. So in this in this first part, the first question they asked me, that is what are the different types of schemas you use in your data warehouse while you build a data warehouse. So let's see what are those. So basically, those are nothing but star and snowflake schemas. So, what are star and snowflake schemas? So, star and snowflake schemas are common dimensional modeling techniques. So, these two are the mostly used modeling techniques to build a data warehouse. So, we'll know what is star schema and what is a snowflake schema. What are the difference between these two? When to use this and when to use it? These all are the kind of questions that were asked among in these two topics. So, let's cover all of them in this video. Okay, so basically these structures organize data into facts and dimensions. So facts mean nothing but a group of data. It has a lot of columns, and few of the columns are gives you the facts data. That is either measurable data, like suppose in the example, suppose if you have a store. Suppose if you want to show the total revenue, that revenue is a column in your fact table. You keep that in your fact table. And dimensions are nothing but, as you know, context for analysis. So there's a store, you have product table, you have a, because you sell a lot of products in your store, so that use products details you keep it in a dimension. So these are high level definitions of what are facts and dimensions. So first, star schema. Let's see more about star schema. It is simple and efficient. And how is a star schema built? It has a central fact table connected to multiple dimensions in a star-like layout. So might not be necessary that you have only one fact table, but it can have any number of fact tables. But a single fact table is connected to a lot of multiple dimensions, and both the dimension and the fact are connected through a one-to-many relationship. Okay, so in the dimension table, you have a primary key, and in the fact table, you have the corresponding foreign key. That's easy to understand. So characteristics, denormalized dimensions, no hierarchy splitting. So basically, suppose if you have customer data as an example, right? So each and every customer has a location. So customer has a location. So say customer belongs to say Hyderabad. So Hyderabad city is Hyderabad, state is Telangana, country is India. So these three columns will be stored in the customer dimension. So for each and every customer, these all values will be stored. So no hierarchy splitting, entire hierarchy will be there in a single table. And fact table stores metrics, example sales data. So just we have discussed. And direct. So there is only single relationship between a fact and a dimension. One to many relationship between a fact and dimension tables. And next, this is the uh, we, graph, or this is the view how a star schema is present. So you have a single fact table, and single fact table is connected to multiple dimensions. So you have so in the dimensions, whatever primary key is there, that will be on the one side, and in the fact table it will be on the many side. So all the primary keys are there in the dimensions, and foreign keys for each of the dimensions present in the fact table. And here, this is sales amount, product cost, quantity. These all are measurable values, factual data. So this is a simple understanding of star schema. And next is snowflake schema. It is organized and structured. Okay. So snowflake schema is nothing but an extension of the star schema, where dimension tables are normalized into subtables. So basically, in the example I have covered earlier, right? So customer table is there. So you have a city, state, and country, all of them uh, in a single table, right? Say if multiple customers belong to Hyderabad, so the city, state, and location for all those customers is the same value, because Hyderabad belongs to Telangana and Telangana belongs to India. So all these three values are always the same. Always the same. Suppose if the customer's location is Hyderabad, then city, state, and country are always the same. So in order, so if you see, in this kind, you have there is a lot of redundant data, a lot of duplicated data. So in order to fix that, we have they have introduced a snowflake schema. So the characteristics are dimensional tables are split into multiple related tables to reduce data redundancy. So what happens? So customer table is split. So what our customer location is there, that also will be a new dimension. So here, suppose if Hyderabad is there, so Hyderabad is only Telangana and India, state and country. So you need not populate all these three values multiple times in the customer table. Instead, in the customer table, you can provide a single key, say customer location key or something, and that key can be mapped to the dimension table. So and second characteristics is requires more complex join between tables, because in star schema you have just a fact table left join a dimension table. Here you have a fact table, left join a dimension table, and that dimension table in turn uh, performs one more left join between another dimension table. So here the data storage is more optimized, but querying is slower due to multiple joins. So here multiple joins are there, right? So multiple joins because um, once first step, first fact table left join dimension A, left join dimension B. So here three tables you're joining, whereas in the star schema you'll just do a fact left join a dimension. There are only a single join is there, and here multiple joins are there. So here querying is slower, but data storage is more optimized, right? So this is the high level view of the uh, snowflake schema. So you have a single fact table and you have dimensions connected to it, and then in turn these dimensions are split into multiple dimensions. Wherever the data redundancy is there, it is split. And key differences between snowflake schema and the star schema. So first thing is the structure. First property feature is the structure. So star schema has denormalized and flat dimensions, whereas snowflake schema has normalized and hierarchical dimensions. So as discussed, right? So denormalized means the data is repetitive. Okay, so you have duplicate or redundant data, and in snowflake you do not have that. Next is joins. So in star schema you have less joins and simple queries, very easy to understand. And in snowflake schema you have more joins and complex queries. And storage. So star schema uses more storage due to redundancy, since the data is duplicated, right? So it will take more storage. In Snowflake schema, it optimized storage with normalization. Since you are normalizing the data, it reduces the storage performance. So star schema has a faster querying because the number of joins there are less, as we had discussed earlier. And in Snowflake schema, it has slow querying due to the number of joins. So here the number of joins are more compared to the star schema. So Snowflake schema is little slower compared to star schema. And next is ease of use. Star schema is very simple to understand and manage because it has only a single one fact and one dimension. Relationship between fact and dimension is one to many. So no internal joins, no internal relationships or joins. So it's very simple to understand. So just a fact table left join a dimension table. And Snowflake schema has more complex design because in the process of normalizing the data, you need to split one table into multiple tables, right? So the design will be a bit complex. And next is advantages of star schema. So simpler queries, direct relationships between facts and dimensions, making querying straightforward. And faster performance, so fewer joins, so queries execute faster, especially for large data sets. Easy to understand, so intuitive layout for end users and developers. And advantages of Snowflake schema: optimized data storage, normalized dimension tables, reduce redundancy and save storage space. And scalable for complex hierarchies, so better suited for handling more complex data structures. And more organized, so data is cleaner and more structured, making making it easier to maintain consistency. So this means, say example, in the customer location only, say or location, so location, say today Hyderabad is part of Telangana, and the country is India, right? So these values never change, but there might be a scenario where you might need to update something, right? Um, like say the customer earlier belonged to Hyderabad, now if the customer has now moved to some other location, or instead of customer, say Example I'm saying, say Hyderabad today is a part of Telangana and a part of India. Say now again, say Hyderabad moved to some other state. It doesn't happen. I'm just saying it as an example. So in the star schema, when you have to update the state or location, you need to the update table will run on multiple records because the same data is duplicated there. So if you want to update that data in Snowflake schema, the number of rows that are getting updated is fixed. So here only one row will be getting updated. So when to use a star or Snowflake schema? So star schema when performance is a priority for high speed queries, for smaller data warehouses with less complex data, and Snowflake schema when storage optimization is critical. Okay, so for large data warehouses with complex hierarchies and relationships, suppose if the size of your data is very less, right? So in that case, your data storage is uh, not at all crucial for you. So in that case, you need performance there. So since you need performance, you'll go with star schema. But say you have a huge amount of data, say TBs of data, where your storage is also very critical, and so in that case, you'll go for Snowflake schema. So which one to use? Star schema, uh, performance and simplicity. So the choice between stars and Snowflake depends on the specific use case. So star schema is performance and simplicity, and Snowflake schema data structure and storage efficiency. And the key takeaways. So if you want the development to be easy and the performance to be fast, you have to use star schema. And if you have complex and very large scale systems, you have to use Snowflake schema. That is the main difference between star and Snowflake. Thank you. Have a nice day.